Good evening, all. In my job, it's not very common to say good evening, all, because usually majority of these sessions and stuff is during the morning and afternoon. It's a great pleasure to be with you, and thank you, Oliver, for invitation. My name is Shahin Rahimifard. As Oliver said, I work in Loughborough University for a very long time. In fact, quite a long time. I've stopped telling students quite a few years ago how long, because they keep telling me this is before I was born. And I said, yes, I appreciate that. In fact, recently we've had an open day in the university. One of the parents was saying, what is your academic aspiration? And I said, to retire before one of you guys came back and said, this is before I was born, kind of thing. So I've enjoyed it immensely. It's been a really interesting experience. I joined the Loughborough to do initially an MSc, then a PhD. Which was on industrial management and was more about IT and so on. And then for a period of 5 years, I visited over 300 companies in more than 10 sectors. And it was all about installing scheduling systems and kind of all different types of ITs at the time. Extended producer responsibility came in. So there was quite an interesting period of my career, learned a lot. But then I became interested in sustainability during his company visits. I saw a lot of things with my own eyes, and so I returned to university just before millennia in 1999 and started a research group in sustainability, which you hear about. I'm part of the Mechanical Electrical Manufacturing School of Mechanical Electrical Manufacturing, and also part of the center referred to as Center for a Smart, which, unlike the use of a smart these days, as more recently the word smart is assigned with digital sort of devices. The smart here stands for Sustainable Manufacturing and Recycling Technologies. We've been invited to change this name. Our argument is always was that we were smarter before anybody else got smart, so we keep the name smart as that. If you want to find a bit about the center, what project we do, obviously I'm going to talk about only one of our projects. That's the website, and there is plenty of information about our other activities. So let's start by an overview of the center and areas that we work and how this has helped us. We've formed a group, the Sustainable Manufacturing Group, in 2001. But the center in university was established in 2004 because, believe me, at that time, it was the only center on sustainability in Loughborough University. And we had requests by multiple of other schools who wanted to be involved. And we were acting as a service provider to a number of schools. As a result, we got involved in a number of different sectors, automotive, aeronautical, rail, apparel, footwear, food, and more recently in medtech. And as Oliver said, we're working through the life cycle of a product all the way from design to its end-of-life management. We've been working with a number of multinationals across these different sectors, working on different projects at the time that they were interested in. So the sort of title of the webinar is supposed to be around sustainability, and it is these days such a broad range of concepts to talk about. It's difficult to sort of talk about sustainability as a whole. Hence, we are talking about resilience and circular economy tonight. But I thought it would be good for those that perhaps have, if that is possible these days, little exposure to sustainability to just remind us why it's become such an important thing these days. So the case of floods, drought, I used to always provide the statistics about increased range of these events, but these days, almost on daily basis, these statistics are becoming old, but it's become quite common to everybody that these are now common occurrence. The climatic change, the wildfires, the global warming, there is enough body of evidence. Perhaps there are other angles of sustainability, though kind of focused, but certainly in the area of engineering not considered as much. the issues about world poverty, and particularly in the case of food sustainability, the area of concern is about global food security. And we've seen also these economic recessions that is happening every 7 or 8 years. It has a significant effect on sustainability and certainly on investment available for changes that we need to make. Now, engineering sector is one of the biggest contributors in the environmental negative impacts, and I'm sure again, you've been involved in some of these, in emission in the air, emission into the water, solid waste. We're going to talk a bit about that. We're generating more. We need more material and energy to make the products. And then there is cases where at the moment there appears to be excessive capacity worldwide to produce, in fact, more than what we need in certain cases, and not as much the case of a food as we need. And we are also being accused as sort of fueling this surge to overconsumption because of a number of activity directly or indirectly related to engineering. Now, as a group of engineers, we realized that a lot of these is as a case of what we've been involved. Perhaps we didn't know the negative impact of growth of engineering and engineering sectors, and these are not by intention. In most cases, this drive for economic growth being the focus of everything hasn't been the focus of every engineers. But one thing for sure is, and I will say that to a lot of our students, is if you're looking at the future challenges, which we talk about some of them, the main solution sort of rely at the heart of engineering solutions. So we should, on one hand, to some extent, feel responsible for causing some of this problem, but on the other hand, be very proud that we are in a position to be able to develop solution to mitigate them. All of these has led to this definition of sustainable development. I'm sure you know. Development that meets the needs of the present without compromising the ability of future generations to meet their own. There is a great argument if you're involved in the global initiative that is happening around this, that this sort of definition is somewhat outdated. When we were talking about future generations, we were talking about possibly our grandchildren, whereas now our own life has been impacted. And in the COP28, there's an argument that this definition needs to be considered, and we have to update really what do we mean by sustainable development. But current definition is that, and based on these three major pillars, three bottom line is sometimes referred to as environmental, economical, and social. Those of you who are really interested in this have seen the fourth pillar of sustainability emerging, the area of culture, which is of great interest. As a result of these development and sustainable kind of development concepts, UN has defined 17 strategic goals for 2030, which is again more commonly known as SDGs, United Nations Sustainable Development Goals, that an SDG being the abbreviation of that. And it covers a wide range of targets, from zero poverty, hunger. Majority of activities that we're involved is in SDG 12 on responsible consumption and production. But then there is extension into quality of education and gender equality and so on and so forth. So majority of companies and international organizations now, they're aligned their initiative, their strategies, their investment to one of these SDGs. So it's become very common for the people to be aware of these 17 SDG. However, something that hasn't changed in engineering when we talk about the product as such, kind of in the larger scale, is that manufacturing industry is still obsessed with cost and giving consumer what they want, because they believe that this too is a success, the kind of secret to the successful, profitable organization. Now we kind of realized that this has created all of those negative impacts, the cracks that we see in manufacturing industry. And the current attitude is that sustainability is a further pillar that is going to come and do a patch job, and is going to sort of make all of these negative impacts and bad news around some of our manufacturing activities to go away. But in reality, we know that that's not possible. What we really need to do is fundamental root cause changes, understanding the current pattern of mass producing products that have got a very short shelf life and are difficult to then recycle and remanufacture and in the life. This pattern cannot be sustained. So in our kind of terminology, we say we can improve our eco-efficiency of our technologies, our engineering solutions. But if we don't deal with the consumption, these benefits, these efficiencies that we gain, never going to catch up with this increased demand on the products, as we see in the case of medical sector later in this presentation. One of the other things in this area that you need to consider is the size of the change, is the radical nature of the change. So if you have a look at where our negative impact is starting, how is increasing, and when we started appreciating that these are impacting our ecosystem, we need to do something with all of those international initiatives, starting from United Nations Environmental Program, or UNEP, all the way to what's now become an annual, almost a meeting attended by many people with limited or no results, or at least visible and tangible results, the COP 26, 7 and 28. If you actually see, well, how much benefits we gain from this versus the negative impact that we cause, I don't think there is any argument among the research community that our net impact is still going up. So we know the impact of our CO2 and greenhouse gases on our global warming, and we're still generating more CO2. We know the impact of lots of these emissions to airs and to waters and plastification of ocean. We know all of that, but still, day by day, our net impact is increasing. Now, the result of this is that the question is, where do we need to go? What do we need to do? Some people kind of see the target of net zero, if we can actually manage somehow through the both reduction of greenhouse gases and sequestration of some of these gases, stop this incline, then that will be the dreamland. But a lot of people, again, who are involved in this, they say that in reality, net zero is a great target to have, but it's not going to solve our solutions, because at the moment, what we're experiencing is based on the result of what we've done in the last 50 or 60 years. It is going to take, depending on who you listen to, the target of 2030, 2035, 2050. There's going to take another 15, 20 years to get into net zero. Hopefully we do. But even then, we're going to find in a totally changed environment that we need to adapt to. So as a result, we need these radical changes. We need these radical improvements in the way that we develop, use our products, and we sort of maintain our lifestyle. So a broad sort of consideration of sustainability. I'm not going to zoom on this concept of resilience and circular economy, which is become equally important for manufacturing sector under this umbrella of sustainability among some of the now strategies and missions, is through globalization of manufacturing, we find that in most sectors, we've got a very, very complex, long, as it's called, supply chain, manufacturing supply chain, where the raw material is generated one part of the world, the products manufactured in differ is being used in another part of the world, and then possibly sent for rework or recycling in a different part of the world. And we're using all means of logistics available to us: road, sea, rail, through the air freights and stuff, carrying that millions and sometimes billions of tons of material around, and we're going to work on this and hopefully see some of that as well. Now, resilience comes through the two concepts that has been shocked at this supply chain system. One is through various disruption, like for example, COVID, who's kind of quite clearly closed down the global supply chains for over a year and a half, some would say 2 years, and resulted in a huge scarcity of products and stuff around the world. In a much smaller case, we had a blockage of Suez Canal, where again disrupt the global supply chain of all type of products and everything else, and it led into the shortage of the goods that we're interested, whether it being food or whether it being spare parts of our products, whether it's been microchips that we needed to make our digital products and stuff. Basically shook the whole essence of these global supply chains through disruptions. But besides that, it has also been appreciated that another reason for this importance of resilience is the scarcity of material. When there is a lot of talk about which is important, energy or material, we seem to be kind of now being obsessed by energy due to the climate change and impact. But there are very encouraging developments there in terms of our future sources of our green energy. One will argue that if investment wasn't a challenge, we would have been able to more rapidly move towards use of renewable energy and so on and so forth. But when it comes to material, I think perhaps it hasn't been totally appreciated, although it's been well spoken and talk about that there is a finite amount of resources available to us. And at some point or other, if we go through the way that in a linear way, we dig a hole, we get these materials out, we use it for a period of time, and we dig another hole and put it back into a landfill, this is going to run out. We cannot continue doing that. So another concept which is sort of shaping this concern over resilience of a supply chain is not only the disruptions, is the accessibility to the raw material that are needed to make our products. And when we talk about this second reason of concerns over resilience, the concept of circular economy has been promoted as a way that it gives us a better use of material, using them for much longer, using them, if at all possible, in a closed loop way. And then that will address our sort of demand on materials and be able to make everything a bit more sustainable, more resilient towards the future. It is definitely a great move, and this is something that I think everybody is promoting, that we need to go from a linear to a circular economy. However, we have to take this with a pinch of salt to realize that even if we go to a circular economy, if the demands and consumption carries out exactly the same, as again, we see this in the case of the medical devices, even circular economy wouldn't be able to sort of provide access to all of the materials, certainly in the quality that we need based on our current technologies. Because as I'm sure the previous speaker, which obviously I have not been a part of the presentation, may have highlighted, is majority of our end of life management, certainly on material recycling, to some extent degrades the quality of the material. So you can go around the loop for so many times before that material is not feasible to be used for the same purpose. So yes, it's a great move, and we are very excited about it. We feel it's a no-brainer that it has to be done. This idea of linear economy, as we see shortly, cannot be sustained. However, we always say that's not the total answer. That's not the silver bullet. You know, we need to consider this issue of consumption as well. So in the old days, there was a talk about 3 R's: the reuse, the recycle and remanufacture, and so on. But since 2011, and thanks to Elena MacArthur's foundation, we have now coined this sort of term circular economy talking about reusing our product, which, as you can see in this slide, you have a technical cycle represented by the blue color, which is the material that we mine, in reusing of that in different ways. Or if you talk about even a renewable material, we need to consider how at the end of life they are kind of used, and there is the green circles, if you like, that is reflective of this circular use within this concept of circular economy. So let's talk about size of a problem, because at all of this, one thing that is really of great interest, as we were talking about, is the size of a challenge in front of us. When it comes to this circular use of material and access and demands of materials, I'm sure you may have actually seen some photos like this in terms of impact of mining on both environments, and at the top middle you may see the impact of the mining in water. The top right, you see the impact of mining into air emission, and at the bottom you see a lot of social ethical issues about some of the lifestyle that and dangerous work that some people have to go through for us to be able to have access to this material that we need. Alternatively, you may have seen similar pictures about amount of waste that we generate, and that is increasing in rapidly. And again, a lot of social ethical issues that are attributed to use of these material. But there are also huge number of statistical charts and stuff that you may have come across. This is showing, for example, the growth in plastic production, which appears to double every 10 years in terms of our reliance and demand on more and more plastics. With everything that we know, by the way, I am not one of those people who's anti-plastics, and it's not war on plastics for me, it's war on inappropriate use of plastics, because it is a sort of a material with great benefits in number of different sectors and so on. But it is alarming the way that we are relying more and more, having to produce more and more. You may see alternative charts that are talking about shortage of certain material, like in this case, cobalt, that we need for a range of our recent developments, from use of batteries into electrical cars, electrical transportation. The current projection is that by 2030, we will have around 150,000 tons deficit in amount of cobalt that we need, based on the growth pattern of our digital world and amount that is currently produced. There are lots of social political concerns about where this cobalt is generated and what will happen, whether would access be available to everybody. And with all of these level of production rapidly increasing, shortage of material and so on, we still see that in different regions in the world, the amount of waste generated is also increasing. So again, there is an inevitability about this that is not something that we don't know about. It's something that we know very much the concerns, but the pattern of our life is in a way still contributing to this negative impacts. Now, to put this size into some sort of something that we can actually perhaps visualize, I thought let's walk through a couple of examples on this issue of linear economy. So I'm going to give you a couple of figures, and we're going to walk through it and see, well, if we want to visualize this, what is 27 million tons of waste? So UK household generates 27 million tons of waste. These are these black liners that are, I like to put in those plastic liners, but these days in the black bins and through the curbside collection in UK, very effectively they collected 27 million tons of this stuff. So you look at 27 million tons and said, well, that's a figure I can't sort of envisage what it is, but I can see it. So there is this organization called face.org. They said, well, at the time where they were changing the double deckers in London, they said, well, if we wanted to carry all of these 27 million tons with double decker buses, how many double decker buses do we need to carry all of that? So they bought one. They put as much as they can of these black liners into double decker buses, and 10 tons of of this waste to fill up one of the double-decker buses. So you divide one to the other and you say, well, we need 2.7 million double-decker buses. Each bus is around 13 meters. You multiply 2.7 million by 13 meters. And if you queue them head to toe, it will be about 35 million meters or 35,000 kilometers divided by 1,000. So this is the visualization part. The distance between London and Sydney, Australia is 17,000 kilometers. And this is the kind of really the moral point of the story. The annual UK household waste can fill a queue of double-decker buses from London to Sydney, Australia and back. Okay, so that's a significance of 27 million tons of waste. Now, if you think that's bad, let's look at the material supply side. Now, globally, the annual mining and growing sort of figures for all of the materials we use in all of our industry is put around 50 billion ton. Okay, I have a look at 27 million and I have a look at the 50 billion, so that's much bigger. But how big is that? So let's do a similar thing. We said if we were to carry all of these materials that we mine in different shape or grow in agricultural formats and everything else, with the trusted transporter on the road, which is a 44-ton lorries. I'm sure you've seen a queue of these in every motorways. How many of these lorries do we need to carry 50 billion tons of material? So you divide one to the other and it's 1.1 billion lorries. Each of the lorries are 16 meters. You know by now where we're going. You multiply one to the other, that's 17 billion meters or 17 million kilometers. You divide one to the other. So what is 17 million kilometers? I was trying to find a distance between two cities, perhaps bigger than, longer than from London to Sydney, Australia, and couldn't find anything that makes it meaningful. So I sort of said, what's the distance between Earth and Moon? And it's 384,400 kilometers. So you divide one to the other, and here's the moral point of that story. Annually, we extract enough materials to fill a queue of 44-ton lorries from Earth to Moon 45 times over. Okay, so that's the size of a problem that we need to deal. It's not about let's reduce here 5%, let's recycle this 10% of plastic, let's just take a few of these kind of high value digital products that we can resell and refurbish and resell them. This type of incremental approach is not going to solve our problems. That is really the message in this slide with this type of visualization. So let's see this in now our medical sector, medtech sector. In almost every sector, there is a definition of perfect storm. I'll be really surprised in whatever sector, if you're working at, you haven't heard, oh, there is a perfect storm brewing up. And here's the perfect storm in medtech sector. We're having aging population globally, across the world now. There used to be different parts of the world, but now in Europe, in North America, in Far East, there is this common sort of longer life, which is a good news. In fact, we need to celebrate it. But then as a result of that, we need more medical devices to be able to deal with this aging population. There are increasing range of medical treatments being offered, which is, again, we have to be thankful for, because allows us to treat lots of more illnesses very effectively. Each of these treatments need more and more medical devices to be treated, some by requirement, some because we're doing a single use. These days, if you have a scratch on your child's knee and you take him to A&E, the first thing that you have this bandage, single-use devices being unwrapped, which may have anything between 80 to 32 devices in there, where 2 or 3 is being used and the rest have been sort of sent to disposal. We've seen the growth from reusable to single growth because of convenience, because of economics, because of shortage of skills, because of pressures on healthcare providers in terms of time and everything else. And then majority of all of the things we're talking about is about the 20-25% of global world population who have access to this advanced healthcare. Imagine the other 80-75% of the population wants the access to the same sort of medical treatments and stuff. Now you put all of that, that's a definition of perfect storm, which is leading only to one thing, and that's a resilience of the medical device supply chain. Are we going to get enough materials? Will we have access to enough materials, particularly when you're competing with all of the other sectors who have demand for the similar materials like cobalt, to be able to address this perfect storm or growing challenge, whichever way you look at it. As a result, there was a strategy document published by Department of Health and Social Care last year, February 23. And guess what? The first priority is resilience and continuity of a supply of medical devices, because they appreciate what's been used in their hospitals and all of the things that we were saying and the demands on this. And I think the question was quite clear. Where are we going to get access to all of these raw materials? I mean, we are now leaving the economic connotation of this to one side. We were just assuming that the budget of NHS can increase on 10 or 20 or 30% every year to catch up, and funding was not an issue. How are we going to access this amount of material to make all of these medical devices? So as a result, in September 22, together Loughborough University, together with University of Leeds and Nottingham Trent University, started a project which was on circular economy of medical devices or small medical devices. And the project abbreviation project title is REMED, as you use reuse and recycle and stuff, remedicine or remedtech. So we're using this title of REMED. The project is due to complete February next year. The team consists of 5 investigators, 5 academics from these 3 universities, 7 researchers. Further information again about this particular project is on the website www.remed.uk. We've had our first conference, which I believe Oliver has attended, and just announced the date for our second conference, which is on the 17th of September 24. The flyer has been distributed and it's on that website as well. So if you're interested in this area, it's free to attend, but it's limited number. And we've got a number of partners at a different sort of a stage of a supply chain. So we have Surgical Holding, who is the manufacturers and also resellers of product. We have Valpak and Sharper Smart, who are the reprocessors of these medical tech. We have hospitals who are actually providing us with a lot of data about what's happened to these medical devices. And we have a research institute on surgical medtech, which is providing us with, again, further insight from medics, from the sort of medtech professions in terms of what they expect from the product, what challenges they find. So not enough. And in fact, these are our, what we call a core partner. These are involved in our proposal. Our user groups now exceed 120 companies and organizations who are working with us in this project. Now, the project is divided into the 3 sort of work stream of assessing products and then looking at the life cycle of them all the way from design to material, reprocessing, production, but also operational and economical consideration around this circular economy that we need to consider. And the hope is that what we do is any learning that we have is going to be put on digitally searchable reference models where all of the medtech will have access to it. And depending on interest that you have, there are some data there of interest. It may not be actually the product we are looking at, and we had to do that because there are over 20,000 different types of medical devices. So we couldn't obviously work on all of those. We've used this metrics of value versus complexity to create this quadrant and looking at series of products that are low value, low complexity to all the way on high value, high complexity, and in between, and identify 8 specific case study product. We are putting them through this life cycle view all the way from their design into material that they use, how they've been produced, how much they cost, how they're used in hospitals, what sort of operational changes needed if you go from single use into multi-use, and then what reprocessing you need to do that. So these are, if you like, our case studies where we're hoping to generate all of those data, new knowledge that is going to be saved in our reference models and made available to medtech in UK and internationally. The hope is that they will then kind of find some alignment between their product and one of these 8 case studies. And we appreciate this is totally insignificant in terms of numbers, because when we talk to our industry, they said in reality we need case studies around 100 and more to be able to be representative of all of the medical devices, but there is always limit on finance. Just to finish off, I'm going to very quickly go through a number of examples of what we've done, what we've worked at. So on the design, this is an inhaler. They come on different types. This is the one that based on an aluminium canister holding a certain drug, and then by pressing that, you amount of drug is released into your mouth where it helps with breathing. We are looking at both reusability and recyclability, so making it in a way that the body, which is often made of the plastic, can be easily separated from the metal part, which is the canister, and in case of recycling. But as you see on the bottom right, we are also looking at refillable canisters. So is it possible to actually give a larger canister of the same drug to the patients where they can refill or recharge their canisters and keep using it rather than having to sort of get new ones every time, so extending life that way. We are looking at laparoscopic scissors and what materials in there and where they're coming from, where they will go. As we talked about in circular economy, it's not always possible to have a fully closed loop in terms of collect the products, recycle its material, and make the same product endlessly with it. So there is this issue of where the material comes, what it gets recycled, and this concept of material sink, i.e. where would you use the material that you've recycled? And in healthcare, that is a challenge through concern over infection and decontamination. So we're doing a lot of material flow analysis and seeing the impact of if you were to actually recycle and reuse that, would we environmentally cause more harm? I know this is a strange concept because at the moment, majority of LCA is done on the production side, where we're thinking, what are the life cycle impact embedded in the production and use of a product? But if you think about recovery as a stage, it really is very similar. It involves transportation, it involves use of energy, use of equipment, sometimes use of materials and all of that to recycle. So you have to consider life cycle assessment of end of life as well as production to see by doing that, in fact, are you benefiting or creating more problems? In the issue of sort of operation and supply chain flow of material, there is a lot of obviously questions that need to be answered. If the sector is used to this single use and a flow of products, production and flow of products in that way, if you introduce circularity, what will happen? What will happen to the batch sizes? What will happen to the sort of stock levels that you need to keep? What happens to the resellers? What happens in hospitals and so on? So there is a lot of what if, where we're using a simulation model to ask those questions and create data in terms of what will happen to the product flow through the supply chain. There is also inevitably, if industry is involved, and also in this case, because the user of the medical tech is being patient, and quite clearly the prime concern and reason for use of this medical device is to make somebody better. it can't be a primary consideration. The circularity can't be a primary consideration. It does not, it should not have an impact on the patient safety, and then there is lots of health economics in terms of where would the medtech is going to gain their future income from if it's not single use? What will happen in hospitals? Would you actually do any saving by reprocessing your medical devices rather than using them? Who would do it? How much they will charge? Do you need more staff in hospitals to actually deal with the collection and segregation of these medical devices? So there is lots of cost models and economical consideration as well that needs to be done. Then on reprocessing, we are looking at two aspects. We are looking at reuse and remanufacture, and we're trying to introduce automation and robotics because there are two reasons. One is, again, in medtech, one of the concern is infection and contamination of the things. So being in a safe environment, you want to use robots for separation of the waste and also doing anything onto the products as opposed to human being involved in that reprocessing. So we're using a lot of vision systems and robots in sort of product recognitions and separations, as well as remanufacturing. And then on the right hand side, we are looking at what materials you can gain from these low value, low complexity products, and what material characteristics you gain from the recycled material when you will be able to reuse that. As I said, we hope that we'll be able to put a lot of these information all the way from design and materials and all into our reference models about these 8 case study products, and to make this available to MedTech to use as example, hopefully to modify and change some of the activities around their medical devices. I hope through these very brief presentations, we kind of realize that sustainability is an evolving concept, and there are new things that almost now on the weekly basis come up to say, oh, by the way, we need to concern this, we need to be concerned about that. And this circularity resilience is now is a rapidly growing concern in industry, which necessitate a huge range of new capabilities, all of the ones that are in that triangle: agility to be able to deal with different materials, security of your materials to ensure that you can trace the source of your material, your flexibility and robustness. I'm not going to go through that due to the time, but you could see that really companies are now needing to sort of be more proactive about these ideas and gaining this capability. So my final remark is, whichever way you look at it, whatever things we talked about it, hopefully these are all been an indication that no action is not an option. All of these are complex, all of these are very difficult. Nobody will actually undermine the complexity of what we're proposing by circular use of medical devices. But our questions are common at the end is that if we didn't do that, what are we going to do? So there's no action is no option comes from there. Our motto in Center for Small is one person can make a difference and every person should try. I'll thank you for your attention. We need at times to make brave decisions. Our solutions are relying on making those brave decisions, and we need to make more of those brave decisions to be able to address our global sustainability challenges in years to come. At this point, I'm going to stop and invite any questions that you may have.
I'm not sure if you can see the chat, Shahin. If not, I can read out a question that's in there.
Can you please read them out?
Yes, absolutely. So seeing the amount of waste generated by UK households is frightening. As engineers, what can we do, or what are the steps you would consider that we can take to ensure that our designs and products do not have a negative impact in terms of sustainability and reducing the amount of waste generated?
A very good questions and a very rapidly growing area of what's you can put it in the umbrella of design for circularity. And under that, there is lots of other design for recycling, design for reuse, design for remanufacturing. Basically, we extending the design challenges, where in the past we had a standard approach of product conceptualizations into the detailed design, into production, end of life, and a lot of issues on end of life were not considered in earlier stage of design. We believe that all of this needs to be embedded on our future design processes, on our future design methodologies. Now, I can provide a lot of examples, but perhaps the example of inhalers that we talked about it, there has to be 3 or 4 very simple design changes, like, for example, identification of material and product that allows us to effectively separate the right material together to be able to recycle them more effectively without impacting the material quality. The ability to have canisters that can be recharged so you don't have a single use of generating those, but the ability to recharge it and use it multiple of times. So there are lots of examples for these design considerations that allows us to sort of come up with the products that at the end of life that are easier to deal with. So that's on the engineering side, on the design side. But then on our supply chain, um, there are lots of things that come into it, which is wide ranging. For example, our business models, which currently rely on this linear economy of selling more to gain more income. We need to kind of consider these circular business models. I encourage everybody to look this up. There are no approaches that you can actually make money, but not at the cost of environment. There are lots of concepts about servitization. There are lots of sort of concepts around multi-user product by different people, different to servitization in different manners that allows us to still generate income, but not at the cost of environment. So in summary, as a designer, as an engineer, as people in businesses, there are a whole series of things that we could do to reduce the amount of waste that we generate at the end of life of the products.
Thank you.
Great, we've got a couple of other questions. So when designing in electronics, what advice do you have for aiding the reusability of items such as cameras? Is this something that would be available from your model?
Interesting questions. You may actually have seen a design that has been put together for mobile phones based on modular design of our product, in that products are made to be upgradable rather than on single use. So if you buy, hopefully in the near future, a mobile handset, you have the capability to change and adopt your product to the specific needs that you have. This concept of product for life is something that is gaining a huge amount of interest. Is it possible for us to have a product structures and then be able to adapt that to our needs? So if you want a better camera, you may actually have multi-use for it. You may have to say, well, I'm going out to take some photography, so I've got my cameras on my mobile handset. Oh no, I'm just going to share some music with my friends and I need a louder speakers, and I will exchange that with the speakers. So this adaptable products that allows your use to be done that. Now, if you do this, what will happen is you reducing a demand on these new digital equipments or digital components and PCB boards and touch screens and hard disks and microchips and all of that. Because when it's on the single use sort of model, the linear model, a lot of people can argue that, yes, you can still refurbish this and resell it and stuff. But there are lots of then economical and consumer behavior that limits the impact of that. So for example, if somebody offered you a mobile handset, for example, iPhone 13, as a refurbish on a fraction of price, you may be tempted. You may just say, well, paying less than half of a price and refurbished and remanufactured, yes. But if somebody offered you a remanufactured iPhone 4 or 5, and I'm not sure even it existed 4 or 5, I know iPhone 6 existed, then I don't think there is a huge amount of market for that. So you see that this concept of reusability, remanufacturability, there are lots of things, and this technology obsolescence, there is market demands and stuff that limits the impact of how many times you could use. So the answer to the question is we could do many things. We could make the products reusable at the end of life, or come up with these structures where we adapt our product rather than changing everything in there and making new ones and creating this waste at the end of the life.
Brilliant. So I think we've got time for one more question. Actually, I can see that this one is a two-part. So as designers, are there any tools that we can use to assess the whole life impact of our designs? And then in addition to that, I'm concerned that my colleagues and I are focusing on the initial supply chain and energy consumption to the detriment of other aspects of the life cycle, which may require other compromises to be made to give better overall sustainability.
Okay, so I'm going to answer the second question first by putting you at rest to say that you're not the only one. We are really dealing with similar situation on the daily basis of various companies now realizing that's the case and coming to us and kind of working through this. So by no means be downhearted that you are one of the few. You are among the majority currently, but that's not a good news. Now, are there any tools that you could do that? Yes, there are many. At the moment, the main tool available to us, the most comprehensive tool available to us is called life cycle assessment. There is a standard methodology in terms of adopting this tool. There are 4 stages in this standards called ISO 14040. And that will allow you to identify the negative impact of your environment during various stages of your product life, all the way from material preparation to end of life. The concept is very complex, so I can't explain it briefly, but do look it up, Life Cycle Assessment, ISO 14040. Now, unfortunately, it's a very complex, very time-consuming approach, but there are now a lot of streamlined LCAs, various footprinting technologies, whether that's energy, material, water, carbon footprinting, where it allows you to assess, perhaps not in the same level of details, but you can get some feeling about the overall impact of the product that you design. If you need more information about that, please get in touch with me and I'll happily provide some more information for you.
Brilliant. So it's nice to see there are so many more questions coming in. I'm conscious of time, but I think we can probably sneak one more in before wrapping it up. But I'm happy to pass on any other questions to Shahin later, and I can get back to you. I'm going to read through this one quickly, just because it's a slightly longer one. So by comparison with medical sector, dealing with household waste is relatively simple. However, so little has been done in respect to simplifying the different plastics and different types of plastics used for packaging, putting you deal with it responsibly into FMCG, which is the fast-moving consumer goods manufacturers, i.e. these should form an associate to collect and process the packaging after use and so on. Why is so little being done and why so slow? Where are our leadership?
Okay, very good questions. And I share some feeling and similar thoughts. But one thing I've learned working in this area over 30 years, it really doesn't pay to point fingers and blame one industry over the other or one sector or the other. We have to have that feeling of we are all in it together and every person should try because every person can make a difference. Every sector should try. Okay, so I think I agree with a lot of things that you say. Believe you me, 30 years of going through this has caused a few gray hairs in terms of seeing lots of things that you want to change overnight, but you can't. So yes, that is a shared feeling. However, I could tell you that I'm working with packaging industry. There is a huge range of sort of initiative on sustainable packaging, on use of plastics, use of biodegradable plastics, and better labeling of plastics, simplifying the range of plastic that has been used. So even on, for example, changing the color of the lid of your milk bottle to ensure you don't create color pollution by having them red, green, and blue. It's been a step in direction where your plastic can be used. Very light level, very high level, but I just want to give the good news that on sustainable packaging, there are huge advances being made on anything. I'm not sure the name of the person who's asked the question, but I will go back to this on just about everything. Is the speed we're dealing with it fast enough? No. No, in reality, no. We really need to improve and redouble our efforts, extend our capabilities, invest in new research and innovation much more than we do. And I don't think just household waste or plastics are the one. On all of the other sectors, one will hope to see more advances being made more quickly. On the positive side of it, I could actually see that there was a lot of time where there was a challenge in persuading people to take the next step. Now, the size of these challenges and some of the things we talk about is taking the option out of their hands. It's no longer about it is the icing on the cake, it is a cake itself. And lots of companies are heavily investing because they realize they would not survive if they don't change and readapt to the new environment within the next 10 or 20 years. So the outlook is very positive in that area. But perhaps one would like for people to move on a bit quicker, as all of us would do in this area of sustainability.